Hello, everyone. My name is Rob. Hruska. I work here at Hudl. So my normal day-to-day job doesn't really involve a whole lot of front-end engineering in the way that we kind of think of it. I'm kind of a back-end code kind of person. So I don't design a lot of user interfaces or things that get used by our customers or anything very, very frequently. I usually, if I'm in JavaScript, I'm usually writing tools for myself or writing tools for the small team of people I work with. But since I work on the back end, I have a lot of interesting data that I kind of want to look at in fun and exciting ways. So, and I think JavaScript is a really great platform for visualizing really high volume data in real time. So one of the things I do, so we have a lot of data. We have a system that's kind of clustered, so we have a lot of communication that happens in between those clustered nodes. And when I try and think about how I want to look at that data, I'm really, I can do it with logs and I can do it with queries into our log aggregators or with our metric systems and stuff like that. But I really want to view it in real time. That's usually where I'm going with it. I want to see what's happening right now. And I think JavaScript is really useful for that. If you want to code up a quick UI, you've got JavaScript, you just open it up in a browser. You've got your code and your UI right there. If you want something on the server, just spin up a node server with a quick application, and you've got server side. So you don't even have to context switch if you're writing a little application, both between the server and the client. So one of the visualizations I've been working on recently is one called Warp Drive. And so what Warp Drive does is, so this is Warp Drive. I've been working on this off and on for the past few months or so. So what this is, if you look at the top and you look at the left, this is all of our systems that we have, and our systems can make API calls between each other. And this was something we introduced this year, and I really, we knew that it was happening, but we didn't really know exactly what it looked like, what the shape of that data was. And so if you look across the top, that's all of our servers. And then across the left used to be all of our servers. Just imagine that this bottom part was shifted that way. I just couldn't get the whole square in the browser, so I had to rotate it. So what happens is every time a server on the left makes an API call to a server on the top, I pulse the square at that node. And I increase its opacity by a little bit for, in this case, about 30 seconds or so, and then I bring the opacity back down. So this is all real time. This is our data in production, real time. This isn't sampled or anything, and it's not really delayed. It's pretty much happening right now. And so with this, you can see exactly what's happening in the system, right? You see that this communication between this cluster and this cluster here is heavier than the rest of them. You can see these trends of things where one server is making a whole bunch of calls to a whole bunch of other servers. So being able to view this data in real time is really powerful. And hopefully I can kind of convince you that by the end. So using some simulations, my desktop computer out there, it's a Core i5, it's got a dedicated graphics card. I can get about, let's see, so right now I'm doing probably 150 or so events per second, getting ready to this visualization here. With simulations, I can get it up to about 30,000 events per second. And I haven't done a whole lot of optimization, so I think I can probably get it up to about 100,000 events per second. Just with straight JavaScript. I'm not doing really anything fancy here. But what I'm going to do here today is kind of show you some of the tips and kind of tricks I use to make this happen. Because really, it's pretty simple. So how does this work? Let's take a look here. All right, cool. So what's happening here is we have a whole bunch of applications, and every time they fire a request off to each other, what they also do is they also fire a metric event that has some information. They use UDP, which is pretty quick. And they send it to a service we have called Riemann. We didn't write Riemann. It's a JVM-based service. It's written in Clojure. That's not super important. What's really important, and the thing that I like about it, is that it gives you this WebSocket stream that you can subscribe to and query events off of. And it makes that really easy. So what I do is that front end you just saw, in the JavaScript, I just create a WebSocket client. And I hook up to that Riemann WebSocket stream, query some specific metrics, and then boom, a whole bunch of data coming across that stream. And the data is really, it's this really simple payload, right? I just have the source server, the destination server, some status information on how long it took. So really small events, but pretty cool. So how many people have worked with WebSockets before? A few people? Okay. So WebSockets is just a bidirectional communication mechanism between browser and the server usually. And this is really all it takes to create or to subscribe to a WebSocket server that's out there. This is what's running in the client you just saw there. The first two don't really matter. Those are just the query string I'm querying from Riemann. But what we basically do is I have this listen function that I define myself. I pass it a callback, so every time I get an event, it's going to execute this callback function. And then I just create a new WebSocket with the URI and bind that event handler to its onMessage event. So the onMessage event, for this case, super simple. I do a little bit of transformation in here from the original event, but it looks pretty similar. I stripped a little bit of code out of here, but basically just parse the data as JSON, and then I invoke this message callback. And so I load the page and I just call listen, and I've got my stream of data, and all I really have to do is define this onMessage function, this callback for it. So see, I don't know if that's how it's supposed to be. Okay, anyway. So, I've lost myself just a little bit. Okay, yeah. That's what I was supposed to do. So what happens on the client side, when the page loads, is it basically queries a list of all the servers we have in my system, and it draws out this grid. And what it's really doing here is, it's not actually drawing a grid. This is just a canvas element, this whole rectangle here. It's not really drawing out a grid. It's basically just going through those server lists and plotting out coordinates that it needs to use to reference certain points, these intersection points. And what it does is it just stores those all in this map. And so I've got this giant map with one entry for each possible node that could get hit here. So the map just looks like this. I use this really kind of hacky key, right? I just take the first server, underscore second server. I know our servers don't have underscores, so not a huge deal. And I build up this grid that has the X and Y coordinates and its current opacity, really, is what I have. So this has got a ton of data in there. And then, so when I receive one of those messages across the WebSocket, here's my onMessage callback. I get that message, and what I do is I build a key from the source to the destination, and then I get that map is called squares, right? Each individual square. I find the square, and I basically just say, let's give it an opacity, or let's take its current opacity, and add a delta. So however much I want to increase the opacity every time I get an event, that's what I'm adding there. And then I just set it, right? So let's leave those last two lines off here for a second. Who's familiar with request animation frame and how it's used? Used a lot in gaming. Okay, not a whole lot of people. All right, so when you want to do an animation in the browser, people usually jump to this kind of standard function called request animation frame. But what request animation frame does is it basically says, all right, you pass me a function, and that function is what I'm going to use to draw my window. So it's going to try and execute this function at 60 frames per second, so 60 times a second. And anything you do in there, it's going to paint that really rapidly. 60 frames a second makes for pretty smooth animation. So my point there is that request animation frame is like a default for animation. And if you look at what I'm trying to do here, right, this is kind of animation-like, right? It's real time, moving fast. But what I found, I actually tried request animation frame first. I actually found that it wasn't the best solution, at least as I was prototyping, to get this done. Because normally what you do with request animation frame is you have your state managed independently from your rendering. right? So you have something in the background, somebody's clicking and they're updating the position of a player in a game, and that is done independently, completely independently of the drawing. But here I'm actually coupling together. So I get the event, and I take my canvas context, and I clear out the square, and I draw a new square with a new opacity. So just kind of an interesting thing there. The defaults may not necessarily be the best solution, especially if you're trying to prototype. I think I could squeeze more performance out of robust animation frame with some optimizations, but this is fairly hacky, and it actually gets the job done. So it's all contextual. So the other part here, this last function, clear activity after. What I do, so I've updated the state of my object, right? It's got an opacity, and after 10 seconds or after 30 seconds, now I want to bring that back down, bring the opacity back. So I just call this clear activity after function. And this, what this does is it basically creates a callback function, closes around some variables, and then just does a set timeout call. This is, if people are doing, do a lot of game development here, they're probably cringing right now with the way I'm doing things with this set timeout. Because that's something request animation firm to take care of for you too. So I create this clear activity, and it basically does the opposite of what I did up there. It says, all right, what's your current opacity? Let's drop it by the delta that I originally increased it by, and do my canvas operations again. These 31 lines of code are pretty much everything that I needed for this app. All the rest of it, there's some counters on there, there's some UI controls, but at the core of it, it's basically just this. So, this is pretty this is all pretty prototyping up front. I just kind of wanted to see if I could get this done, but really, it shows what you can do with just prototyping stuff in JavaScript, and so that's, I don't know, JavaScript's a pretty powerful tool for doing those sorts of things, and you can get really damn good performance out of it. 30,000 events a second without really any optimization isn't really anything to scoff at. I'm cramming functions onto the event loop here really rapidly. So a couple lessons learned here. Cache everything, right? If you want fast performance, don't loop. You never want to loop inside of something like that. I didn't really care about memory, so I've got this huge, 40,000 item map sitting there with all my state, but everything I do in there is a constant time lookup. So I sacrifice a lot of memory for performance with this. And then, if you have any references to DOM elements that you need to keep track of, cache all those as well. Just keep references, don't relook them up every time, especially in those two critical functions that you're executing all the time. Speaking of maps and storing state, who here is familiar with the event loop model that the JavaScript or the browsers usually use? Okay, a few people. So what event loops are is basically it's kind of JavaScript's concurrency model, basically. How everything works in JavaScript, it's all functions, right? And all these functions get processed by this single-threaded event loop. So what it means is that only one function is ever executing at a given time. And what's great about that is that if you have this state that you're manipulating, you are guaranteed to only have one function ever mutating that, right? Nothing else. You have 6 or 7 threads you need to lock around to try and maintain that state. So you're basically given concurrency. Your autonomous operations are given to you. And that's a really powerful concept to work with if you don't have to worry about locking and lock contention. So just another great thing about JavaScript that I kind of really realized as I was working on it. So this is a pretty, this has turned into a pretty critical tool for us. It started as a prototype, just a way to visualize the data, but it's actually really critical. What you're seeing here, I usually use it when we do deploys of the code. And one of our applications deploys, when we deploy, we take half of our servers offline and deploy the bits to that and then switch over. So this is as the deploy is beginning, right? We're taking traffic away from these 3 chunks of servers and moving over. And even just a couple weeks ago, I had Warp Drive open as we were doing a deploy, and all of a sudden, poof, nothing. There was nothing in this grid. And that's a really scary thing, because that means that nothing is happening on our servers. And since I had this open, I knew about it in seconds, not minutes, seconds. And so I was able to jump on that problem and say, crap, something's wrong. Go check a couple of other places. We immediately realized what was happening. And we do have alerts that would have told us that, but those alerts are at minute granularity at best. So the fact that we had this stuff happening in real time, it pretty much paid for its time right there. and that's great. So yeah, basically, if like JavaScript isn't just for UI development, you can really get a lot of throughput and a lot of high volume traffic pumping through it without doing a whole lot of work. You know, the real-time nature of the visualizations is powerful. I can speak firsthand about that. And prototyping out with JavaScript, the event loops, that guaranteed concurrency, you know, just kind of help. So that's about all I got. Any questions?
You mentioned the guaranteed concurrency. Could you ever see yourself like having some evolution where you're using web workers?
It's crossed my mind. I haven't thought about what that means. Because even with web workers, right, you're using message passing between them to send information back and forth, and you're not necessarily mutating the state from them. So I think you're still pretty much guaranteed that concurrency. It's just you have to think a little bit more about it. I haven't thought much more about it than that, though.
I haven't really found a use for web workers yet,
Yeah.
so that's why I'm
It might be a great place to try them out. Like, if I find, as I'm trying to get this up to 100,000, like, that might be something I try out just to see what that does. Yeah.
Rob, did you try the different browsers for the performance?
No, I basically just ran this in Chrome. That's pretty much what I use. So, and like, I had the benefit of just developing it for myself and for my team. So, I didn't really care that much. I know that like some of the counter things I'm doing in the bottom, like Internet Explorer doesn't do toggle class right, so they basically go like back good, back good, back good, back good with their classes. It's kind of fun. Yeah.
I have 3 suggestions for you, but I'll bring them up afterwards.
Okay, cool. Nice talking to you. All right, thanks.
cool.